Good morning, my YouTube viewers. It's Crystal here. I'm just here this morning because I wanted to do another code review. This is code that I've been working on the past several days. I was working on the jacks. Basically, yesterday I did a code review for you for predicting on just regular house prices. And I used jacks, but I do have to admit that I made a mistake on whenever I was calculating the data frame. And so the prediction didn't come out correct, but other than that mistake that I made when I was sorting out my X and my Y values, the code was correct except for that fact. But what I'm doing in this particular code review, we're using California house prices that comes with Google Colab. So if you've got Google Colab, which you should be able to have it because it's a free online resource by Google, then you can do it with California house prices, no problem. And what we're going to do is we're going to take the code and we're going to run the code up, and we're going to compare it to sklearn's linear regression and see which one comes out the best. I will say that I was looking for the source code for sklearn's linear regression, but it was a lot of code because obviously these people that make the source code to these libraries, they've been working with computer programming a lot longer than I have, so they know a lot more than I do, and so I decided not to use the source code for sklearn's linear regression because it was quite complex, and what I wanted was something simple. So what we're going to do in this particular code review is we're going to use the code for the linear regression that I used in the last video, but we're going to use pandas and sklearn to run the program, whereas the one yesterday we were just using NumPy and JAX. So now that you know what we're doing and what we have done in the past, then what we'll do is we'll get started with the code review. And I wrote this program in Google Colab, and you can too. I got the data set from the sample data sets in Google Colab, the California house prices, and you can too. So what we're going to do, the first thing we're going to do is we're going to import the libraries. So we're going to import pandas as PT, which creates your data frames and processes the data. We're going to import NumPy as NP, which creates the NumPy arrays and carries out algebraic functions, linear algebra to be precise. We're going to import JAX, which is a new library. It's come out in 2018. This library is supposed to be overtaking TensorFlow, and the reason why is because TensorFlow has Keras in it, and Keras enables people to make their own models, whereas JAX is more difficult to use because it's like NumPy, but it's more powerful. It's more powerful than NumPy, but it's written like NumPy. We're going to import SciPy because we're going to do some scientific calculations to compute the z-score. We're going to import Matplotlib, that's to visualize the data. And then we're going to import Seaborn, which is statistically visualize the data. I'm going to take out this make regression because we don't need it because we're using California house prices. One thing that I did find out when I was doing all this research was that the linear regression models, the complex linear regression models for JAX worked if you created a data set using sklearn's make regression. then it would work. But if you took an off-the-shelf data set, it didn't work. And as a result of that, I had to take a very simple linear regression program in NumPy and convert it to JAX. And that was the only way that I could get it to work with any kind of reliability. But what I would like to do is keep working on it and see if I can get it some code that will make it usable. But until that time, I'm just taking a very simple linear regression model from NumPy and converted that to JAX. After we import our libraries, then we're going to set the seed in both JAX and NumPy. We're going to load up our files. Our files are coming from Google Colab. And then so what we had was we had a train file and a test file. So what we did was we just concatenated the train file and the test file. We reset our index, and we actually dropped the index because you don't need it. The reason why you don't need it is because in pandas, every row is automatically indexed anyway. So you've got your longitude, your latitude, housing median age, total rooms, total bedrooms, population, households, median income, and median house value. Decided I was going to remove the outliers, so we're using the z-score to remove the outliers. df equals df np.s z-score df is less than or equal to 3, all axis equals 1. So it moved about, we lost, I think there were 20,000 rows, but when we removed the z-score, we only had 19,128. So I think that's 872 rows that it got rid of. We're going to define our dependent and our independent variables. Y is your dependent variable, so y equals df.pop median house value, and then y equals jnp array y. We're going to convert it to array. We're going to create a map with the latitude and the longitude, and that looks pretty good. It looks a lot like the shape of California, I suspect. Now we're going to make some scatter plots. I will say that the map, we used Seaborn to create the map, and Matplotlib to create the labels. With the scatter plot, we're going to use Seaborn, and then we're going to take the median income as opposed to the value of the house. So you can see, like, the higher the income, the higher the value of the house, ostensibly. And then what we're going to do is we're going to take a scatter plot, and we're going to say the total rooms with the value of the house. So you can see the more rooms you have, the higher the value. Now we're going to ask for the total bedrooms, and you can see the more bedrooms you have, the higher the value. Now we're going to make a box plot, and we're going to say the median house age. So what's interesting, so that just tells you the age of the house corresponding to the value of the house. The next thing we're going to do is we're going to define our x variable. So x equals df. So x is the data frame with everything except the median house value. And now we're going to split the data set up into training and data sets. So x equals jnp dot array x. So we converted x into an array, a JAX array. And then what we're going to do is we're going to standardize the cell values. And so x equals x minus x mean over np dot stdx. And then we're going to use train test split to split the data up into training and testing sets. So we're going to analyze the target. So that's what the target looks like after the outliers have been removed by using the z-score. We're going to create a linear regression model with JAX. So you're going to do the normal equation, and then we're going to function, and then the prediction function. And so what I had to do was, because I couldn't get any of the linear equation models in JAX to work, so I had to take a linear equation model in NumPy and I had to convert it to JAX. So after we've taken our functions, normal equation function, which calculates the beta and returns the beta, and the prediction function, which returns dot product of x test and beta, we calculate our predictions. So you've got the predictions. Calculate the RMSE, that's root mean squared error. So that's 67531.23. And we plot it on a graph. So this is what it looks like plotted on a graph. And now what we're going to do is we're going to compare it to linear regression in sklearn. So we're going to use sklearn's linear regression, and we're going to plot the prediction. And our RMSE is 66613. So the RMSE in sklearn's linear regression is slightly less than it is in the linear regression model that we made. And now we're going to plot it on a graph, and so you can see there it is plotted on the graph. But what I was thinking about is what I was thinking is that what I would like to do is I want to normalize it and see what happens when I normalize it. What I want to do is I want to see if the RMSE improves if I normalize it, because you can normalize the data, which means you take the data and you convert it to a value between 0 and 1, or you can standardize the data, and standardize the data is based upon its standard deviation. So we're looking over here, and we've got our RMSE with normalized data 66646, and RMSE with sklearn is 66618. So actually, when we normalize the data, it gives you a better error than it does when you standardize it. So that's really what you're supposed to be doing. You're supposed to be checking it to see what it is normalized, checking to see what it is standardized, and checking to see what it is with nothing when it's not normalized or standardized, and then select the best error. So we just checked to see what it was normalized, and we had a better error, so we decided to go ahead and use that. So I'm going to go ahead and conclude this code review because we've gone over the code, which is what we wanted to do. So I would like to thank my subscribers for supporting my channel. If you like my video, please like, subscribe, and share. If you want to be notified whenever I make a new video, then please tap onto the bell button next to the subscribe button. And thank you so much for watching my video. I look forward to making more code reviews for you in the future.